Today we are going to learn implementation of full adder using two half adders. First and foremost thing we have to understand is what are the equations for full adder? We all know it. Some equation is full adder has got three inputs. Here I have taken inputs as x, y, c in, and one will be the output sum, the other will be the output carry. So I denote inputs as x, y and c in, and sum as s, carry as c. Try to understand this. Now I just want to tell you that first we understand what are the equations for the full adder, Boolean expressions. We all know that three inputs, sum has got x or y, x or cn. This we know it. And carry is xy plus xcn plus ycn. So these are the two equations. Now we have to try these two equations to get these two equations similar like a full adder making use of a two half adders. Here I am going to draw the block diagram, I am going to draw the logic diagram, then I am going to reduce the equation, or I am going to derive the equation so that expressions so that I should get a similar expressions like a full adder. See these drawings. First drawing is a block diagram. I am using two half adders. One is, this is the first half adder, this is the first half adder, and this is a second half adder. Alright. So first half adder has got two inputs x and y, and it will generate first sum and first carry, and that is third input cn is given as an input to the second half adder, and previous half adder sum is given as an input to the next half adder. The sum is generated, and the carry of previous half adder and the current half adder both are combined with the OR gate, and carry is generated. This is a block diagram. This is complete is a block diagram. Alright, this block diagram I have drawn making use of a logic gates. Dekho. So we all know that half adder has got a one XOR gate, one AND gate, two half adders, two XOR gate and two AND gates. But one OR gate is there to combine the carry of two half adders. So this XOR gate will take input x and y. This XOR gate will take a sum of the previous XOR as an input, then cin as another input. So I can write x is equal to x XOR y XOR cin. This you have understood. Now the thing is we have to work on the carry. So carry for this XOR is generated with the inputs x and y, and carry of this half adder will be generated making use of a sum output of a previous, that is HA1, and carry input, and the carry of first half adder and carry of a second half adder both combined to the OR gate to get a final carry. Now this we have understood. It is very simple that S is from x, y and cn. So I write x XOR y XOR cn. Sum is very simple. Now the final carry is generated using C1 and C2. So I write C is equal to C1 plus C2, y plus it is ORing. What is C1? C1 is x and y. What is C1? C1 is x and y. And what is C2? C2 is S1 Cin. Now what is S1? S1 is XOR y. What is XOR y? X dash y plus y dash x cin. Now make this equation little clear. Xy multiply cin, x dash y cin plus y dash x cin. Alright. Then xy I can multiply with one term which doesn't matter at all. Term is cn plus 1. What is cn plus 1? It is 1. So doesn't matter at all if we multiply this term to xy. So I write this as it is. I multiply xy with cn and again xy as it is. Now this xy I multiply with cn plus 1, which doesn't matter because cn plus 1 is 1. Boolean law. This and this. Again multiply xy cn plus xy, x dash y cn, y dash x cn. Now keep xy as it is, this xy as it is over here, then you can take out the common one. This is in this and this. Which is the common? yc in. When I take yc in, it remains x plus y, x dash. And in this case, I take xc in. Just a minute. In this case, I take xc in as a common, and here also xc in. I will be left with y plus y bar. Then x plus x bar and y plus y bar is equal to 1. We all know it, that is Boolean law. And finally we got equation xy plus ycn plus xcn. Compare this equation with this equation which I have written initially. It is one and the same. So with this circuit, with this 2 half adder, adding only one OR gate will give us a full adder. Have you understood this? So in this, first I have written expressions for full adder. I have drawn truth table for the full adder. I have drawn the block diagram, then the logic diagram. With this logic diagram, I tried to get the expressions for the half, that is a full adder, for carry and the sum. I got the same expression as written initially, so hence proved that I can implement full adder making use of a 2 half adders. Only one logic gate is required, that is OR gate, which will give us a full adder. I hope this video is helpful for you. I will give this notes, this PDF, that is this notes on your Moodle, but this video will help you to understand this. Thank you.